Hello, so this is called Learning Check 1. It's going to have two problems that you solve. This is a great way to check your progress and see how you're doing with finding those equations, because sometimes that's the hardest part, to figure out which equation to start with. So that's why we use that guess process to help you out through there. When you do these learning checks, the best thing to do is to do it the whole way as far as you can, and then listen to my solution, and then maybe go ahead and try it again. I know you think that repetition is boring and tedious, and yes, it very well might be, but it's also what gets that pathway kind of firm in your brain on, oh, this is what I forgot to do, but I got it again this second time. So my word problem skill is improving. And no matter where you're at right now, when you get to the end of physics, your word problem skill will be improved. So the first problem is an ATV increases speed from 10 meters per second to 17.7 meters per second when they hit an open stretch of trail. If this took 8.0 seconds, what was their acceleration? So this is the point where you want to actually do the work completely out on your notebook. Some of these quizzes, I'll have you submit work for points. Sometimes I'll have you just answer questions on the actual quiz. So, but always take your notes so that you can fix your notes, and then you have good references for any of those assessments upcoming. So go ahead and hit pause. And welcome back. Now, if you were like, I really have no idea where to go, remember that thing that you want to have with you all the time is those equations from the formula sheet. And so I know it's kind of a little blurry part of it, but that is just there just for a reference. You really do want to make sure that you have your reference sheet with you literally at all times, that you can make little notes and hints on as you're going through it. And that is what you can use for the quizzes and tests, your formula sheet with your notes in there. And so what is that guess process? We want to find the givens and identify what they are. An ATV increases speed from 10 meters per second from, so that means this is our initial or start velocity, VI, to 17.7 meters per second. This is our final velocity when they hit an open stretch of trail. Okay, this took 8.0 seconds. That's a time. What was their acceleration? So our givens, VI, VF, and T, physically either circle them and label them or write them over here. 10 meters per second, V final, 17.7 meters per second, time 8.0 seconds. Get a system. If you already have one that works, then just go with that. Underline the unknowns. That's the one with the question. The unknown is the question, so that acceleration is what we're going to be looking for. Now we go back over. We have VI. We have VF. We have time. We are looking for acceleration. So what information do we have? Which problem is going to let us solve it right now? Okay. For the top one, we would still need distance and average velocity. For the second one, oh, we have change in velocities actually. So V final minus V initial, we could use that. And why is that? Because these two equations are basically the same. They're just rearranged. Okay. We could not use this guy because we don't have the distance yet. Okay. But so what equation am I going to use? I'm going to use the V final equals V initial plus AT, because that's just arranged a little bit easier. V final 17.7, V initial 10. Acceleration's what we don't know, and time is 8. Okay, what am I going to get rid of first? The 10, 7.7 plus A times 8. Now I need to get rid of the 8. And then I'm going to get out my calculator here. 7.7 divided by 8 is equal to 0.9625. And what are my units going to be? I have meters per second and second, meters per second, or meters per second squared would be your acceleration. And then if they asked you for the distance, could you go back and get the distance now? Yeah, because now we have that acceleration. So we could use either of these formulas to find distance. Okay. When you write your answer out, magnitude is the number, units, meters per second squared. They didn't give me a direction, so I can't actually solve it with a direction. So this would be a scalar right now, unless they gave me a direction. And that is problem number 1. Problem number 2, Sam does a warm-up of 200 feet at 2 meters per second, then accelerates at 0.25 meters per second for 50 meters, and finally stays at that new pace for the remainder of the 400 meters. How fast did they run? So again, if you're having trouble with the math, at least go through and set up your guess. Get as far as you can, and we can always go over the math or watch some. This is where you can watch some Khan Academies on how to solve the algebra problems if you're getting stuck with that and don't have time for Q&A or one-on-ones. Okay, so go ahead and hit pause. And welcome back. What do we know? 200 feet, that's the first distance. And at that first distance, there is the velocity. Okay, so this is actually velocity 1, because it's a constant one right here. It might also be used as initial velocity later on. But for distance 1, this is the velocity. And then we accelerate. So this is our acceleration at the second part. And this is our distance for the second part. It finally stays at that new pace for the remainder of the 400 meters. Oh, remainder. This is going to be the distance total. Okay, so we got a lot of different things in there. How fast did they run is the final unknown that you have, but we're going to have a lot of little unknowns as we go through. Why? Because we have 3 parts. So we're going to have the distance at the first part, distance at the second part, and distance at the third part is going to give us 400 meters because it says the remainder of the 400 meters. So if we need that distance for part 3, that is that formula that we're going to use here. How fast did they run? Time of the first part, time of the second part, time of the third part gives us our time total. And that is the one that the problem is actually hoping for you to get. Okay. So where are my equations to help us out here? Let's do this all in 3 different parts. So part 1, I have a distance and a constant velocity or an average velocity. Okay, so I have these guys. Can I get my T1? Yep, right off the bat, I'll be able to get my T1. Okay, so this is the walking portion, or I think walk 2 meters per second. That's about a walk. Okay. V equals D over T. What is their velocity? 2 meters per second. What is their distance? 200 feet. Oh, I can't put 200 feet. All right, 200 feet over 1, and I'm going from feet to meters. So from 3.28 feet in 1 meter. And oops, here it doesn't cancel. Feet is canceling here because it's the same on the top and the bottom. 200 meters over 3.28 gives me 60.98. Okay, you don't have to worry about sig figs as much in physics. Physics is not that particular until you get to later. So I'm actually just going to round to 61 and call it good there. 61 meters, and that is our distance of the first one. So that's going to go in this top. 61 meters to give us a time. Okay, so I need to get time on the other side because we can't leave it in the denominator. And that gives me 2 meters per second times time equals 61 meters because those times on the right cancel. And now I'm going to divide both sides by the velocity. And notice meters over meters cancels. And how does that seconds work? Meters over meters per second is meters over 1 divided by meters over second. And when we know when we're dividing by a fraction, it's the same as multiplying by a reciprocal. And so that's how we're left with seconds. So that's just a good double check. That is your unit analysis. Later on, that's going to come super important. Right now, if that did not make a lot of sense, that is okay. Just plug it into the formula and get your answer there, 30.5 seconds. So time 1 over here is 30.5 seconds. Time 2. What do we have? For part 2, we have an acceleration and we have a distance. What else do we have? We have, we have the leftover from the first part. This is the initial velocity for part 2. So sometimes go back and read the whole thing. Go, wait, I don't have enough to solve this. You might earlier in the problem. Okay, so my initial velocity I also have. So on here, I want to find the time. Okay, but when I look at this, for this guy, for the time, I need the velocity final to get to the time. For the second one, I can solve it using this, but I'm going to need to use the quadratic formula. If you want to go right through and do that, that's fine. But I'm looking down here to this bottom one, and this guy is just going to let me solve velocity final right here, which I'm probably going to need anyway, because I'm going to need to know what that new pace is at the end. So if I didn't need to know the new pace at the end, yeah, I would go through and do the quadratic formula. But since I need V final already, I am just going to use that equation for part 2. And this is the accelerating part of the run. V final squared, V initial squared, plus 2AD. V final squared, we don't know. V initial, 2 squared, plus 2 times acceleration, 2 times 0.25 times the distance of 50. Okay. 4 plus 2 times 0.25 times 50 is 29. So V final squared is 29. So V final is going to be a little bit over 5. Don't just assume a little bit over 5. Physically plug it in just like you would in math class. 5.4 meters per second. So even if you didn't do the unit analysis, remember we're doing a velocity, so its units would be meters per second. So now I have my velocity at the end, and now I can put that into that same equation from before. V final equals V initial plus AT. V final. Up a little bit, hold on. Equals V initial plus AT. My V final, 5.4. My V initial, what did I start with? 2 meters per second. My acceleration, 0.25. And my time is what I'm trying to solve. 5.4 minus 2 gives me 3.4 equals 0.25 times t. I'm going to divide both sides by 0.25. 3.4 divided by 0.25 is 13.6. Time is in seconds. Whose time is this? This is the acceleration time. So this is time 2, 13.6 seconds. Now, time 3. They stay at this new pace for the remainder of 40 meters. Okay, so for time 3, we're at a new pace. What is our new pace? What we ended time 2 at. So our velocity final from time 2 is the start velocity for time 3. How far did they go? We need to know that information. So distance 1 was 61 meters. Make sure you're talking apples to apples. Each one of these guys has to be meters. Okay, distance 2, 50 meters. So distance 3 is what we're going to solve for. 400 minus 61 minus 50 is 289 meters in that last section when they are going 5.4 meters per second. And so 289 divided by 5.4 gives me a time of 53.5 seconds. This is the time where they were at pace, 53.5 seconds. Okay, so our total time, 53.5 plus 13.6 plus 30.5 gives us a time total of 97.6 seconds. So well off the world record pace, which I looked up just so that I knew. Usain Bolt, less than 30 or about 43 seconds. So they're about twice as slow as him. And who knows if this was a race or just their practice. Okay, so that is how that you do that one. Again, you can watch it again. I know there's a lot of little sections, and how you can see when I do my work, lots of little sections. Break it down on your paper. You have a little bit more room on your paper than I do on mine. If you're feeling comfortable with this, then yes, go on to the next part. If not, restart it and make your notes nice and neat and organized so that you can follow along if you get any type of problem that asks one of these questions. And have a great day.